Right now, you are reading this in a single moment you would call the present. That moment is not moving, it is not flowing past you, and you are not traveling through it. The physics that governs reality contains no such thing as the present. No sliding now, no line between what has happened and what has not. Your entire life, first breath to last, already exists as one fixed shape in 4 dimensions. This is the block universe, also called eternalism, the reading of Einstein's relativity in which past, present and future are equally real, laid out together in a static space-time whole. And here is the number that makes it concrete. 2 people passing on a sidewalk, differing in speed by an ordinary walking pace, disagree about what is happening now in the Andromeda galaxy by days. Not seconds, days. That is Roger Penrose's paradox, and it comes straight out of the relativity of simultaneity, the discovery that, at the same time, has no universal meaning. Hermann Minkowski put it in 1908. Space and time, separately, fade away into mere shadows. What casts the shadow is a geometry we will examine closely. Einstein, Minkowski, Penrose, Gödel. They all stared at the same structure and saw the same strange thing. So, here is where it begins. Let me start with the claim in the title, because it is the thing you clicked for, and I am not going to make you wait for it. Your life as a static object. What could that possibly mean? And what in physics forces it? Start with the one fact that everything else in this hangs from: the relativity of simultaneity. It sounds abstract. It is not. It is the reason your sense of a shared, universal now cannot survive contact with the evidence. Here is the setup. Take 2 events that happen far apart in space. A light flashing in one city and a light flashing in another. Ask a simple question. Did they happen at the same time? Your intuition says the question has one answer. Either they were simultaneous or they were not. Everyone who checks carefully should agree. That intuition is wrong, and relativity shows exactly why. Einstein's 1905 special theory rests on one hard experimental fact. The speed of light in a vacuum is the same for every observer, no matter how fast that observer is moving. Light travels at 299,792,458 meters per second, about 186,282 miles per second. And it refuses to add or subtract with your motion the way ordinary speeds do. Run toward a beam of light, and you still measure it arriving at the same speed. Run away, same speed. This is not a quirk of instruments. It is built into the structure of the world. And it has a consequence that dismantles the universal now. Picture a train car and a lamp exactly at its center. The lamp flashes. Light spreads out in both directions at the same speed. To a passenger sitting in the middle, the light reaches the front wall and the back wall at the same moment. The distances are equal, the speed is equal, so the arrivals are simultaneous. Now put an observer on the platform, watching the train move past. To this observer, the back wall is rushing toward the point where the flash happened. and the front wall is racing away from it. Light still travels at one fixed speed for this observer too. That is the rule that cannot bend. So, the light reaches the back wall first and the front wall a moment later. Two observers. One says the arrivals are simultaneous. The other says they are not, and neither is making a mistake. Think about a stagehand and an actor timing a pair of spotlights from different positions in a theatre, both using perfect stopwatches. If the difference were about slow signals or reaction time, you could fix it. This is not that. There is no experiment either observer could run to correct the disagreement, because both measurements are exactly right within their own frame of motion. Simultaneity is not something we are failing to measure precisely. It is something that has no single, observer-independent value at all. What does it mean that "at the same time" has no universal answer? It means the intuitive picture, one cosmic present sweeping forward, the same for everyone, has no foothold in the physics. There is no master clock. There is no shared slice of now that carves the universe into a settled past and an open future, the same way for all observers. Hold that. We will build the entire structure on it. Now let me put a number on how strange this gets. Because the sidewalk to Andromeda figure is not a metaphor. It is Roger Penrose's dramatization from his 1989 book, The Emperor's New Mind, of an argument first made by C. Wim Reitdijk in 1966 and independently by Hilary Putnam in 1967. The Reitdijk-Putnam argument. Here is the logic. Each observer has a plane of simultaneity, the set of all events everywhere in the universe that they count as happening right now. When you change your motion, even slightly, that plane tilts. Close to you, the tilt is negligible. But the plane extends across all of space, and the farther out you go, the more a small tilt sweeps across enormous stretches of time. Andromeda sits about 2.5 million light-years away, roughly 2.4 times 10 to the 19th kilometers. At that distance, the difference between two people walking past each other at a few kilometers per hour is enough to tilt their planes of simultaneity by days. So an event near Andromeda that one walker counts as already happening now is, for the other walker, still in the future, not yet occurred. Penrose's vivid version. If a fleet were launching from a planet in that galaxy, one walker's now could include the launch decision as already made, while for the other it has not yet been taken. Same two people, same sidewalk, opposite conclusions about whether a distant event is settled. Here is where the block universe enters. If the events in your now are real, if they exist, and the events in someone else's now are equally real, and their now includes things that are still your future, then your future events must be just as real as your present ones. Reitdijk and Putnam pushed exactly this. Putnam wrote that future things are already real on every natural choice of the simultaneity relation. Run the argument to its end, and you get eternalism. Past, present, and future all exist equally as parts of a single four-dimensional object. No moment is privileged. The universe is not a movie playing frame by frame. It is the whole reel laid flat, every frame already there. I want to be careful and honest here, because this is a place where the reasoning is contested, and we will return to it. The Rete-Putnam argument is an inference. It takes a fact about geometry, planes of simultaneity tilt, and draws a conclusion about what exists. Critics, and serious ones, dispute the middle step. Keep that flag planted. For now, I am laying out the mainstream reading, the one that says relativity most naturally points at a static block. Let me give the block its geometry, because this is where it stops being a philosophical mood and becomes mathematics. In 1908, Hermann Minkowski, who had been Einstein's mathematics teacher, took special relativity and reformulated it geometrically. He fused 3 dimensions of space and 1 of time into a single 4-dimensional manifold, space-time. And he found the quantity that all observers agree on, even when they disagree about time and space separately. It is the space-time interval. Here is the equation, and I will speak it plainly. ds squared equals c squared dt squared minus dx squared minus dy squared minus dz squared. In words, the interval, ds, between 2 nearby events combines their separation in time, dt, and their separation in space along the 3 directions, dx, dy, dz, with the speed of light c as the exchange rate between time and space. The minus signs are the crucial part. Time enters with the opposite sign from space. That single difference in sign is what makes time, time, and not just a 4th direction of space. Why does this matter? Because ds is invariant. 2 observers moving differently will disagree about how much time passed between 2 events, and disagree about how far apart they were in space. But plug their different numbers into this formula, and they get the same interval. The disagreement about now is real, but underneath it lies something everyone agrees on: the geometric distance between events in the block. Minkowski's point was that the true reality is not space and not time, but this unified fabric. Space alone and time alone are the shadows. The interval is the thing. Picture 2 surveyors mapping the same tract of land, one facing north, one facing northeast. They will disagree about how much of a fence post's position is east and how much is north. Those depend on which way you face. But they agree exactly on the straight line. Distance between 2 posts. In Minkowski's geometry, how much time passed and how far apart in space are like east and north. They depend on your orientation, which here means your motion. The invariant interval is the true distance, and it does not care how you are moving. What does it mean that the split between space and time is like a choice of compass heading? It means the boundary between them, including the boundary we call the present, is a feature of the observer, not of the universe. In this geometry, an object is not a thing that exists at an instant and then moves. It is a world line, its complete 4-dimensional trajectory, from beginning to end, drawn once and for all through spacetime. A particle's world line is a curve. An extended body, a planet, a person, is a world tube, a thick braid of world lines. Your body, across your whole life, is one such tube. It begins at a point we label your birth, and ends at a point we label your death. And in the block, it exists all at once, a single static shape. This is the spacetime worm, and it is the literal content of the title. You are not a point moving up the time axis, you are the whole thread. This is the part that stays with me. Not the scale, the geometry. The clean fact that in Minkowski's picture, your life is already a completed curve, and the feeling of moving along it is not part of the curve at all. Let me anchor this in something that actually happened, because so far it is diagrams, and the block universe has fingerprints in real laboratory data. If space and time trade off the way Minkowski said, then moving clocks should run slow, time dilation. And moving clocks do run slow, measurably, repeatably, to the nanosecond. The cleanest early evidence came from muons. A muon is an unstable particle, a heavier cousin of the electron, and it decays with a rest lifetime of about 2.2 microseconds. Cosmic rays striking the upper atmosphere create muons high above the ground, moving at nearly the speed of light. In 1963, David Frisch and James Smith measured how many muons arrived at the top of Mount Washington in New Hampshire, 1,907 meters up, and how many survived to sea level in Cambridge, Massachusetts. Without time dilation, given their speed and short lifetime, only about 31 per hour should have made the trip. They counted about 565 per hour arriving up top, and about 409 per hour at the bottom. The muons were living roughly 9 times longer than their rest lifetime allows, a measured dilation factor of 8.8, plus or minus 0.8, at speeds between 0.9950 and 0.9954 times light speed. The particle's internal clocks were running slow, exactly as the geometry demands. The question that forces itself here: is this some peculiarity of exotic particles, or does it happen to ordinary clocks too? It happens to ordinary clocks. In October 1971, J.C. Hafele and Richard Keating took 4 cesium beam atomic clocks, HP 5061A units, and flew them around the world on commercial airliners, eastward and then westward. The clocks bought their own seats. The flight manifests list Mr. Clock. The whole thing was funded by about $8,000 from the Office of Naval Research. When the clocks came home and were compared to the reference clock at the U.S. Naval Observatory, they disagreed with it, permanently, by tens to hundreds of nanoseconds. And the direction and size of the disagreement matched relativity. The eastward clocks read about 59 nanoseconds behind prediction of minus 40. The westward clocks read plus 273 nanoseconds against a prediction of plus 275. A nanosecond is a billionth of a second. But the clocks that flew were no longer synchronized with the clock that stayed. They had traced different length world lines through the block, and the lengths did not match. That length has a name and an equation: proper time. It is the time actually measured by a clock traveling along its own world line, and it is written d tau equals dt times the square root of 1 minus v squared over c squared. Here, d tau is the proper time, what the moving clock reads. dt is the coordinate time, v is the speed, and c is light speed. When v is small, the square root is nearly 1,
and proper time nearly equals coordinate time. That is why you never notice this walking around. As v approaches c, the square root shrinks toward 0, and less proper time elapses along the world line. Proper time is, quite literally,
the length of your life thread in the block, measured along the thread, not along any external clock. Two threads between the same two events can have different lengths. The traveling twin returns younger not because time played a trick, but because their world line through space-time was shorter. You rely on this every time your phone finds you on a map. The GPS constellation, 31 operational satellites orbiting at about 20,200 kilometers, roughly 12,550 miles up, moving near 14,000 kilometers per hour, carries atomic clocks, and those clocks tick at a different rate than clocks on the ground. Two effects combine. General relativity says clocks higher in a gravitational field run faster. That adds about 45 microseconds per day. Special relativity says the satellite's speed makes their clocks run slow. That subtracts about 7 microseconds per day. The net is about plus 38 microseconds per day. Left uncorrected, that would throw your position off by roughly 10 kilometers per day. So the engineers who built the system did something remarkable. They preset the satellite clock frequency before launch from 10.23 MHz to 10.2299999953 MHz, deliberately detuning them so that once in orbit, dilated, they would tick correctly. Relativity is not a curiosity in this system. It is a manufacturing specification. So the geometry is real. Clocks bend. Here is the foreshadow I want you to carry. These experiments prove time dilates. They prove world lines have different lengths. They prove there is no universal rate of ticking. But notice what they do not prove. They do not show that time flows. A slow clock is still a clock reading off a fixed world line. Keep that distinction. We will need it. The mathematics behind that tilting plane of simultaneity deserves to be seen directly, because it is where the whole block universe is hiding in plain sight, in a single term. The Lorentz transformation tells you how one observer's coordinates translate into another's when they are moving relative to each other. For time, it reads t prime equals gamma times t minus vx over c squared. In words, the time an event has for a moving observer, t prime, is the original time, t, minus a correction that depends on the event's distance, x, all scaled by the factor gamma. The whole of the relativity of simultaneity lives in that middle piece, the v minus x over c squared. Look at what it does. If two events happen at the same time t, but at different places, different values of x, then that term gives them different values of t prime. The moving observer splits apart in time events that were simultaneous for someone at rest. And the further away the event sits, the larger x becomes, the larger the shift. That is the sidewalk stretched to Andromeda, written as algebra. A tiny velocity v multiplied by an astronomical distance x produces a temporal displacement of days. The gamma out front is the Lorentz factor. Gamma equals 1 over the square root of 1 minus v squared over c squared. And for walking speeds, it is almost exactly 1, which is why the near-field effect is invisible. It is not gamma that does the strange work here. It is the humble Vx over c squared, the coupling of your speed to distant space, quietly redrawing what counts as now across the cosmos. What does it mean that a single term in a transformation equation is enough to disassemble the shared present? It means the block universe is not an exotic add-on to relativity. It is what relativity says when you read its coordinates literally. Change your state of motion and the equation reassigns time values to distant events. It re-slices the four-dimensional whole along a different angle. And if the whole must already be there to be re-sliced, then the whole is what exists. This is the quiet radicalism of the Lorentz transformation. It treats the block as a given and merely tells different observers how to carve it. Consider a stack of translucent sheets, each printed with the state of the universe at one instant, glued into a solid, clear brick. A person at rest slices the brick horizontally and calls each horizontal sheet a now. A person moving slices the same brick at a slight angle, and their angled sheets cut across the resting person's horizontal ones. Both are slicing the identical brick. They simply orient the knife differently. The Lorentz transformation is the rule for how the knife tilts with speed. Nothing about the brick changes when you tilt the knife. The brick, the block, is prior to every slicing. That is the geometric intuition Minkowski handed us, and it is why he could say space and time separately are shadows. They are two ways of orienting a cut through something more real than either. Now let me deepen this, because so far I have given you the mainstream picture as if it were settled, and the honest situation is richer. The block universe is a reading of the mathematics. The mathematics is not in doubt. What is in doubt is what the mathematics says exists, and that is where physics touches something it cannot directly measure. Go back to McTaggart, because he framed the whole debate before relativity was even finished. In 1908, the same year as Minkowski, the British philosopher J.M.E. McTaggart published The Unreality of Time, and he drew a distinction that every later thinker uses. He separated two ways of ordering events. The A series orders them as past, present, and future, a tensed ordering, one that requires a moving now that turns future into present into past. The B series orders them only as earlier than and later than, a tenseless ordering, fixed, with no moving present at all. In the B series, the Battle of Hastings is earlier than your birth, permanently. Nothing about that relation ever changes. The block universe is a B series world. Events sit in fixed, earlier-later relations, and the passage from future to present to past, the A series, is not a feature of reality, but of experience. What does it mean that the equations of physics are written in the B series? It means the present tense, the thing that feels most urgent about being alive, this instant being real in a way others are not, does not appear anywhere in the fundamental laws. The laws relate earlier states to later states. They never single out a moment as now.
Einstein felt the weight of this personally. The philosopher Rudolf Carnap recorded that Einstein once told him, "The now worried him seriously," that the experience of the present is something special for human beings, essentially different from past and future, but that this difference cannot be expressed within physics. Einstein found the omission unavoidable, and he found it unsettling. That is a striking thing for the architect of the theory to say. The man who removed the universal now from physics did not therefore stop feeling it. And when his oldest friend died, Einstein reached for exactly this idea as consolation. Michel Besso, his confidant since their student days, the one person thanked in the 1905 Relativity paper, died in Geneva on March 15, 1955. On March 21st, Einstein wrote to Besso's family. The line is famous. "For those who believe in physics," he wrote, "the distinction between past, present, and future is only a stubbornly persistent illusion." He meant it as comfort. If the block is real, Besso had not vanished. Every moment of his life still exists, at its own coordinate in spacetime, not gone, only elsewhere in the structure. Einstein himself died 33 days later, on April 18, 1955. He wrote that sentence about the illusion of the passage of time with roughly 4 weeks of his own world line remaining. I return to that letter often, not because it is comforting, because it shows a mind following the logic all the way, applying it to the person he loved most and to his own approaching endpoint, and refusing to flinch. Let me now voice the objection you should be forming, because it is the strongest one against everything I have said so far, and the fair thing is to give it in full force. If the Reitdijk-Putnam argument really shows the future is fixed and real, why can't we ever see it? Why is the already settled future completely invisible to us? Here is the objection, sharpened by physicists like Howard Stein, Stephen Savitt, and N. David Mermin. The present in relativity is strictly local. Relativity does tell you that simultaneity is frame-dependent, but it does not license extending your plane of simultaneity across millions of light-years and declaring everything on it real now. Mermin put it directly, that no inherent meaning can be assigned to the simultaneity of distant events is the single most important lesson to be learned from relativity. On this reading, the lesson of relativity is not that the distant future is real. It is that distant simultaneity is meaningless. The block, the
localists argue, is smuggled in by treating an abstract mathematical slice as if it were a real cosmic present. This is not a fringe complaint. It cuts to the core of the Reitdijk-Putnam inference, the assumption that co-reality is transitive, that if event A is real to you now, and event B is real to someone whose now overlaps yours, then B is real, full stop. The localists deny exactly that step, and they have a hard physical fact on their side. Nothing you count as now at Andromeda can send you a signal or receive one faster than light. The tilted planes of simultaneity are causally inert. You can never confirm the fixedness of that distant future by any observation because no information from it can reach you outside your light cone. Which means the strongest claim of eternalism, the distant future is already real, is, by relativity's own light speed limit, permanently beyond direct test. Hold that. It is the honest edge, and we will stand on it at the end. The light cone is worth naming precisely because it is the causal skeleton everyone agrees on, even when they disagree about now. At every event, light spreading outward traces a cone into the future and, running backward, a cone into the past. Anything inside your future light cone is something you could, in principle, influence. Anything inside your past light cone could have influenced you. Everything else, the vast elsewhere, is space-like separated from you, causally disconnected. And it is precisely over this elsewhere that observers disagree about simultaneity. The condition for light itself is ds squared equals 0. The interval along a light ray vanishes. That null condition is invariant. So while frames argue about what is simultaneous, they never argue about what can cause what. The causal order is absolute, even where the temporal order is not. Any serious theory of time has to respect that skeleton. There is a place where this geometry does something far stranger than tilt a plane, and it comes from an unexpected direction, not from a physicist trying to prove the block, but from the greatest logician of the 20th century trying to understand what relativity permits. In 1949, Kurt Gödel, Einstein's close friend and walking companion at the Institute for Advanced Study in Princeton, presented Einstein with a birthday gift, an exact solution to the equations of general relativity describing a universe that rotates, not expanding like ours, but spinning, filled with matter turning with an angular velocity given by omega equals 2 times the square root of pi g rho, where g is the gravitational constant and rho is the density of matter. It is a clean, valid solution to Einstein's field equations, and it contains something that should not be possible. In Gödel's rotating universe, there exist closed time-like curves. A closed time-like curve is a world line that loops back and connects to its own past, a path through space-time along which a traveller, never once exceeding the local speed of light, never doing anything locally forbidden, could journey into their own history. The rotation of the matter drags space-time around with it so severely that the light cones themselves tip over as you move outward, until the future at one place points back toward the past at another, and a continuous causal loop closes. Gödel had proven that general relativity, the very theory the block universe rests on, permits worlds in which there is no consistent way to slice space-time into a sequence of global nows at all. You cannot foliate a Gödel universe into past, present and future the way our expanding cosmos seems to allow. Gödel drew a philosophical conclusion, and it is the sharpest argument against objective flow ever made. In his 1949 essay, A Remark About the Relationship Between Relativity Theory and Idealistic Philosophy, he reasoned this way: if there exists even one physically possible universe, one consistent solution of the equations, in which there is no objective lapse of time, then objective lapse cannot be an essential, necessary feature of time itself. Our universe, he granted, expands and does not rotate, so it may happen to permit a global time. But a feature that is present in some solutions and absent in others is not fundamental to what time is. It is contingent, a local accident of how matter happens to be arranged. Gödel used relativity to argue that the passage of time is not woven into the fabric. It is, at best, a feature of certain matter distributions, and therefore, he suggested, an appearance rather than a bedrock reality. What does it mean that you could, in a lawful universe, walk into your own past along a path that never breaks a single rule of physics? It means the intuitive picture that the past is gone, sealed, unreachable, is not a theorem of general relativity. It is a feature of our particular cosmic arrangement, not of space-time as such. Is our universe a Gödel universe? No. Precision measurements find no global rotation. The cosmos expands and shows no sign of the spin Gödel's solution requires. The closed, time-like curves are not in our sky. But that is not the point of the argument, and it never was. The point is what the theory allows. If time's flow were truly fundamental, no valid solution of the equations should be able to abolish it. And yet, Gödel wrote one down. That is a proof about the character of the theory, and it lands whether or not we live inside his spinning world. Now let me take you to the place where time does not merely become relative, but disappears from the equations altogether. The quantum gravity problem of time. This is the deepest and most technical stretch, and I will move through it carefully, because it is where the block universe stops being an interpretation of relativity and becomes a puzzle at the frontier of physics. Ordinary quantum mechanics has time built into its central equation. The time-dependent Schrödinger equation reads IH bar partial psi partial t equals h hat psi. In words, the rate of change of the quantum state psi with respect to time t is set by the Hamiltonian h hat, the operator representing the system's energy. The key feature for us is that partial psi partial t, the change in time is right there, an external parameter, ticking along in the background while the state evolves. This is the physics of change, and it presupposes a clock outside the system. Now try to apply quantum mechanics to the whole universe, including gravity, including space-time itself. When John Wheeler and Bryce-DeWitt worked out a candidate equation for canonical quantum gravity in 1967, they got something that looks almost the same and behaves in a completely different way. The Wheeler-DeWitt equation is h hat psi equals 0. The Hamiltonian acting on the wave function of the universe gives 0. And that changes everything, because there is no partial psi partial t anymore. The time derivative is gone. The equation says the quantum state of the entire universe does not evolve in any external time. It is stationary, frozen. What does it mean that the fundamental equation of quantum gravity contains no time? This is called the problem of time, and it has been open since 1967. It arises because general relativity has no fixed background time to begin with. Time is part of the dynamical space-time, not a stage it plays out on. And when you quantize that, the external clock vanishes. The equation is also mathematically ill-defined in full generality. Physicists usually study it in simplified mini-superspace models, and even there, rigorous, non-trivial solutions are scarce. As one recent review flatly states, the problem of time remains unresolved to this day. So here is the tension laid bare. Relativity already suggested the universe might be a static block. Quantum gravity's best candidate equation says it plainly. The wave function of the universe does not tick. And yet, hold this thought, you clearly experience change. Something has to give. The most elegant attempt to reconcile a frozen universe with felt change came from Don Page and William Wooters in 1983, in a paper with a title that is a thesis in itself: Evolution without Evolution. Their idea: time is not fundamental. Time is entanglement. Divide the universe into two parts: a small clock subsystem and everything else, the rest. Now let those two parts be quantum entangled, correlated so that particular clock readings go with particular states of the rest. The global state, taken as a whole, is completely static. It satisfies the frozen wheeler-dewitt condition. It does not evolve. But an observer who lives inside the rest and who reads the clock sees the rest of the universe change as the clock advances. The evolution is not out there in some external time. It is a pattern of correlation inside a static whole. The equation captures it compactly. The global state is a sum over clock states, each tensored with the state of the system at that clock reading, written as a superposition running over all values t of the clock, pairing clock reads t with system looks like this at t. From outside, nothing moves. From inside, correlating yourself with the clock, you experience a flowing world. Time emerges from the correlations, not from a background parameter. Think of a flip book. Every page is drawn and bound. The book as a whole just sits on the shelf, static, complete. But run your thumb along a corner where the page numbers are printed. Read the clock, and correlate what you see on each page with its number, and a figure appears to move. The motion was never in the book. It is in the relation between the pages and their ordering. Page and Wooters proposed that the universe is like that book, and our experience of time is like reading the page numbers from inside. And here is the part that lifts this out of pure speculation. It has been demonstrated in a laboratory. In 2013 and 2014, Ekaterina Moreva and colleagues at the INRIM Institute in Turin built the smallest possible version, a universe of 2 photons. They prepared a pair of polarization-entangled photons and designated one the clock and the other the system. An observer correlating measurements with the clock photon saw the system photon's polarization evolve, exactly as if time were passing. But an external measurement of the 2-photon state as a whole confirmed it was static, unchanging, stationary. As the researchers described it, A static, entangled state between a clock and the rest of the universe is perceived as evolving by internal observers. Change without change. A frozen hole that looks, from inside, like a flowing world. It is a two-photon toy, not a universe, and it does not prove the cosmos works this way, but it shows the mechanism is real, that a genuinely static state can house what looks from within like the passage of time. I had to sit with that experiment for a while when I first understood it. Not because it is exotic, but because it takes the most private, undeniable fact of your existence, that time is passing right now, and reproduces it as an artifact of correlation inside something that does not change at all. There are other routes to time from something static, and each is a serious research program. Consider Carlo Rovelli and Alain Connes' thermal time hypothesis from 1994. In a fully general relativistic theory, there is no preferred time variable to begin with. Rovelli and Connes proposed that time is not read off the geometry, but off the state of matter, specifically off the thermal statistical character of a system. Using deep mathematics, the Tomita-Takesaki modular flow of the algebra of observables, they showed that a thermal state naturally defines a flow, a one-parameter progression, and they identified that with physical time. T equals h bar beta times the modular parameter s. Time, on this view, is what a thermodynamic state does. It is emergent from the statistics of many particles, not fundamental to the fabric. Rovelli showed the idea can recover the standard cosmological time of an expanding universe from the thermal properties of the cosmic microwave background. The worry, which Rovelli acknowledges, is circularity. Reading a thermal state as genuine equilibrium seems to presuppose some notion of time already. It is a live program, not a finished answer. And then there is Julian Barber, who takes the frozen picture furthest of all. In his 1999 book, The End of Time, Barber argues there is no time at all, not even emergent flow in the deepest sense. Reality, he says, is a vast, timeless space of possible configurations of the universe, each a complete, frozen instant. He calls it Platonia. Each point, he wrote, is a now. I call it Platonia because it is timeless and created by perfect mathematical rules. There is no motion between the nows, and no sequence stamped on them from outside. The powerful appearance of history comes from what he calls time capsules, individual nows that happen to contain mutually consistent records, memories, fossils, photographs, that hang together as if they were the residue of a past. Your sense of having come from somewhere is, on this view, entirely contained in the structure of this single instant, which is full of apparent traces. Barber is candid about the program's limit. He concedes he cannot as yet see any direct experimental way to test Platonia. It is a minority research direction with real technical work behind it. His best matching formalism, developed with Bruno Bertotti in 1982, but no experimental discriminator. What does it mean that our most fundamental theories keep pointing at a reality without time, while our most basic experience insists on nothing but time. That gap is the whole subject. And it is time now to close it, or to close as much of it as the evidence allows, and to say honestly where it stays open. Earlier, I said we would return to the threads. Now we do. Let me lay the competing pictures side by side and weigh each against what the experiments actually show. Start with what is not in dispute, because it is the ground everything else stands on. The relativity of simultaneity is settled physics. Time dilation is settled physics. The muons on Mount Washington, the cesium clocks flying Mr. Clock around the world, the GPS satellites detuned before launch, these are not interpretations, they are measurements, reproduced for decades, agreeing with relativity to the nanosecond. The Minkowski geometry that describes them, the invariant interval, the light cone causal structure, world lines with lengths given by proper time, is as well tested as anything in physics. So any picture of time has to fit this. There is no universal now. World lines have different proper time lengths, and the causal skeleton is absolute, while the temporal ordering of distant events is not. That much the evidence forces on everyone. Now, does eternalism, the full static block, follow from that? Here I have to weigh, not assert. The case for the block is that it fits the geometry with no extra machinery. A four-dimensional manifold with no preferred slicing is exactly what relativity hands you. The block just takes that manifold to be the whole of reality, all of it equally existing. The time symmetry of the fundamental laws points the same way. Neither the equations of general relativity nor those of the Standard Model contain a preferred now or a built-in direction of flow. And the quantum gravity results, from wheeler-dewitt to page-wootters, deepen it. Our best candidate for the wave function of the universe is static, and even the appearance of flow can be reconstructed and demonstrated in the lab as a pattern inside something that does not change. On the physics, the block is the most economical reading. It is the mainstream view for a reason. But the case has a real weakness, and I will not paper over it. The block by itself does not explain two things you experience every waking second: that time seems to flow, and that it flows in one direction. The equations are symmetric between past and future. Your life is not. You remember yesterday and not tomorrow. A dropped cup shatters and never reassembles. Heat spreads and never spontaneously gathers. Where does that asymmetry come from if the underlying laws do not have it? The leading answer is entropy, and it imports the arrow through a boundary condition rather than through the dynamics. Boltzmann gave us the statistical meaning of entropy. S equals KB times the natural log of W, where S is entropy, KB is Boltzmann's constant, and W is the number of microscopic arrangements, the number of ways the particles could be arranged, consistent with what you see macroscopically. High entropy means many arrangements. Low entropy means few. The second law says entropy tends to increase. S at a later time greater than or equal to s at an earlier time, simply because there are overwhelmingly more high-entropy arrangements to stumble into than low-entropy ones. Think of a locksmith with a lock that has 1,000,000 wrong combinations and one right one. Random turning drifts toward wrong, not by design, but by sheer counting. But that statistical argument runs both ways in time, and that is the catch. If entropy is just probability, it should be high in the past too, yet it was not. The early universe was in an extraordinarily low entropy state. To ground the arrow, the philosopher David Albert, building on Boltzmann, argued in his 2000 book Time and Chance that we must simply posit this as a boundary condition, the past hypothesis. The universe began in a very special, extremely low entropy macrostate. Add a rule of uniform probability over the microstates compatible with it. Barry Lower dubbed the whole package the mentaculus, and the thermodynamic arrow follows. Everything that feels like the flow of time on this account is you climbing the entropy gradient the past hypothesis set up. Memory, aging, cause preceding effect, the sense that the past is fixed and the future open. The flow is not in the space-time, it is in the one-way slope of entropy across a block whose fundamental laws know no direction. Does the past hypothesis fully close the case? No, and honesty requires saying so. It names the low entropy beginning. It does not explain it. Why did the universe start in so improbable a state? That is not answered. It is assumed. And critics, John Earman, who titled a paper The Past Hypothesis Not Even False, and Eric Winsberg, dispute whether a global cosmic boundary condition can really underwrite the entropy increase of small, isolated systems here and now. So, the best current account of why time seems to flow is entropy plus a special past. And that account works well and is incomplete at its root. There is a second frontier where the static block turns from an interpretation into a genuine physical worry, and it involves the arrow of time from the opposite end. Not the low entropy past, but the high entropy far future. It is called the Boltzmann brain problem, and it is one of the strangest self-consistency tests in all of cosmology. Ludwig Boltzmann, in the 1890s, working with his assistant Ignaz Schütz, floated a bold idea to explain why we find ourselves in a low-entropy, ordered universe. Suppose the cosmos as a whole is in thermal equilibrium, maximally disordered, over unimaginably long stretches of time. Even in equilibrium, random fluctuations occasionally produce pockets of lower entropy, ordered regions, just by statistical chance. Perhaps, Boltzmann mused, our entire ordered world is one such gigantic, rare fluctuation out of the equilibrium sea. The problem, worked out much later, is devastating in its arithmetic. If order arises by random fluctuation, then large, elaborate, ordered structures are exponentially rarer than small ones. A whole galaxy fluctuating into being is astronomically less probable than a single ordered brain fluctuating into being with false memories of a galaxy already stitched in. So, in an eternal equilibrium universe, the overwhelming majority of self-aware observers would not be evolved beings in real galaxies. They would be isolated, momentary consciousnesses, Boltzmann brains, that flicker into existence out of the disorder, complete with fabricated memories of a past that never happened, and then dissolve back into equilibrium. If you take the fluctuation story seriously, you should conclude that you are, with overwhelming probability, one of these. Your memories are false. The room around you is a fluctuation about to vanish. This is where the finiteness of a certain number becomes decisive. In a universe dominated by a cosmological constant lambda, as ours appears to be, spacetime approaches a de Sitter state, and a de Sitter horizon has a finite temperature and a finite entropy. The temperature is T equals h over 2 pi, where h is the Hubble expansion rate, and the entropy is S equals 3 pi over g lambda, where g is the gravitational constant and lambda the cosmological constant. That entropy is astronomically large, but it is finite. And finite entropy plus infinite time is exactly the recipe for fluctuations. Given forever, every allowed configuration recurs, including Boltzmann brains, endlessly. So a cosmology that predicts an eternal de Sitter future predicts that ordinary observers like us are wildly outnumbered by fluctuated ones. Why does this matter for the block universe and the arrow of time? Because it is a reductio, a scenario used to rule cosmologies out. The physicist Sean Carroll put it precisely. Boltzmann brains constitute a reductio ad absurdum, a demonstration of the silliness of a certain kind of cosmology. And the reason they are fatal is subtle and beautiful. Carroll calls such a scenario cognitively unstable. If you concluded that you were probably a Boltzmann brain with false memories, then the very memories and reasoning that led you to that conclusion, your knowledge of physics, of entropy, of de Sitter space, would themselves be fabrications you could not trust. The conclusion undermines the premises that produced it. You cannot coherently believe you are a Boltzmann brain, because believing it destroys the reliability of the thought that got you there. What does it mean that we use our own coherence as evidence against a cosmology? It means the arrow of time is doing work far deeper than shattering cups. The past hypothesis, the low entropy beginning, is what makes our memories reliable records of a real past rather than lucky fluctuations. It is the reason the past is knowable and the future is not. And the Boltzmann brain argument turns that around into a constraint on the whole structure of the block. Any cosmology in which fluctuated observers dominate is one we can reject, not because we have measured it false, but because if it were true, we could never have measured anything at all. This is the arrow of time defending its own foundation. The low entropy past is not just a boundary condition tacked on to the static block. It is the condition that makes the block intelligible to observers inside it. There is one more serious idea to weigh, and it is the most disorienting of all, because it does not merely deny that time flows. It questions the direction we assume causes must run. This is Hugh Price's case for retrocausality, laid out in his 1996 book, Time's Arrow and Archimedes' Point. Price's starting move is methodological, and it is sharp. He argues that when we reason about time, we constantly smuggle in our own temporal perspective, our built-in assumption that causes come before effects, that the past is fixed and the future open, and then mistake that perspective for a discovery about the world. He calls for an Archimedean point, a view from outside time, from nowhere within the flow, from which we do not presuppose any direction at all. Take that view, he argues, and demand that the fundamental physics be genuinely time-symmetric, treating past and future on exactly equal footing. And something remarkable follows. The something is a possible resolution of the deepest puzzle in quantum mechanics. Bell's theorem shows that quantum correlations between distant, entangled particles cannot be explained by any local theory that assumes the measurement settings are independent of the particle's hidden properties. The correlations seem to require either faster-than-light influence or the abandonment of ordinary locality. Price points out that there is a third door, one we usually refuse to open because of our temporal prejudice: retrocausality. If the future can influence the past, if a measurement choice made now can affect the state of a particle emitted earlier, then the correlations can be restored to a local Lorentz invariant picture without any faster-than-light signaling. The particle knows about the future measurement, not because information travels backward faster than light, but because the influence runs along the ordinary time direction, in reverse. A genuinely time-symmetric quantum ontology, Price argues, points toward exactly this. Think of an accountant reconciling a ledger who insists on reading every entry top to bottom. Some totals never balance until the accountant allows themselves to read a later entry as constraining an earlier one, to let the closing balance inform how an opening figure must have been recorded. The books were always consistent. The trouble was the insistence on one reading direction. Price argues quantum mechanics may be a ledger like that, consistent and local, if only we stop insisting that influence flows one way through time. Developed further with Ken Wharton and Peter Evans, this is a minority view, and Price is scrupulously honest about its limits. Retrocausality is fiendishly hard to reconcile with our sense of control. If the future shapes the past, in what sense do we freely choose our experiments? And whether time symmetry strictly implies retrocausality is disputed. Price himself wrote in 2012 that on this question, the quantum world says maybe. But note what his program shares with everything else in this landscape. It takes seriously that the fundamental level has no built-in arrow, and it treats the one-way flow we experience as something to be explained rather than assumed. The muon experiments have a sequel that closes one of the last escape routes, and it is worth stating because it removes an objection you might reasonably raise. When the hafele-keating clocks flew, or when muons raced down through the atmosphere A skeptic could ask, is it really the speed that slows the clock? Or is it the acceleration, the turning, the buffeting, the forces? In 1977, J. Bailey and colleagues at CERN settled it. They stored muons in a ring, whipping them around at a Lorentz factor gamma of 29.33, moving so fast that their lifetimes stretched by nearly a factor of 30, confirmed to about 0.1%. But the crucial finding was about acceleration. The muons in the ring were subjected to transverse accelerations of order 10 to the 18th times the acceleration of gravity, a staggering force, and their lifetimes were unaffected by it. Only the speed mattered. This is the clock hypothesis. An ideal clock's rate depends on its instantaneous velocity, not on its acceleration. The dilation is purely a matter of the path's length through spacetime, the proper time integrated along the worldline, not of the forces felt along the way. The block does not care how violently you are shaken. It cares only about the geometry of your thread. That geometry is captured exactly in the equation Hafele and Keating used to predict their result, and it shows the two faces of relativistic time in one line. The clock difference is the integral over the trip of a gravitational term minus a velocity term. The difference in gravitational potential divided by c squared, minus the difference in the squares of the velocities divided by 2c squared. The first term is general relativity. Higher up, in weaker gravity, clocks run faster. The second is special relativity. Moving faster, clocks run slower. They carry opposite signs and they compete. For the GPS satellites, the gravitational effect wins. The altitude speeds the clock more than the orbital velocity slows it, which is why the net correction is positive, plus 38 microseconds a day. For a low, fast-moving clock, the velocity term can dominate instead. The eastward and westward flights of Hafele and Keating differed precisely because flying with or against Earth's rotation changes the velocity term's contribution. Two effects, opposite signs, integrated along the worldline. The clock that comes home reads the proper time length of the specific path it traced through the block. No more, no less. There is a strand of this story that predates relativity and reaches into pure logic, and it sharpens what is really at stake. Return to J.M.E. McTaggart, whose 1908 argument for the unreality of time set the terms. McTaggart's claim was not merely that time is static, it was that time, understood as involving real passage, is self-contradictory. His reasoning, the A series, past, present, future, is essential to any real change, because change means an event being future, then present, then past. But those three properties are mutually exclusive. No event can be all three. The defender of passage replies, of course, an event is not future, present and past all at once. It is future, then present, then past, in succession. But in succession already invokes another time in which the change of the change happens, and that second time faces the same contradiction, requiring a third, and so on without end. McTaggart concluded the A series is incoherent, and since he thought real time needs it, time is unreal. The B series, earlier and later, survives his critique intact, because those relations never change and generate no contradiction. It is no accident that the block universe is a B-series world. It is precisely the picture you are left with when you keep McTaggart's fixed ordering and drop the moving present he showed to be paradoxical. Not everyone accepted the surrender of the present. The New Zealand logician Arthur Prior spent his career in the 1950s and 1960s building tense logic, a formal system in which it was the case that, it is now the case that, and it will be the case that are irreducible operators, not translatable away into tenseless earlier-later relations. Prior was defending the A theory, the conviction that tense is a genuine feature of reality, that there is a real difference between an event's being present and its being merely later than something. He offered a famous example. When a painful experience ends, we say with relief, "Thank goodness that's over." What, Prior asked, are we thankful for? Not that the pain is earlier than this utterance. That tenseless fact was always true and always will be, and no one feels relief about an eternal fact. We are thankful that it is past now, that its presentness has drained away. The relief seems to point at something the block universe says does not exist, an objective now that the pain has fallen behind. It is one of the most stubborn arguments for passage, precisely because it appeals to something everyone has felt. What does it mean that our language is soaked in a tense that our fundamental physics does not contain? Here, the block universe gives an answer that is coherent, if cold. The relief is real as a psychological event. It is a state of the observer at a particular coordinate on their world line, a state that includes memory of the pain and its absence in current experience. What it does not require is that the universe possess an objective present. The B-theorist grants that, "Thank goodness that's over," expresses a genuine feeling and denies that the feeling tracks a metaphysical fact about which moment is lit up as now. The feeling is a fact about you, located in the block. It is not a fact about the block having a moving spotlight. Whether that reply fully honors the force of Prior's example, or whether it explains the feeling away rather than accounting for it, is exactly the sort of question the evidence cannot adjudicate. Which is why philosophers of time still argue it, a century after McTaggart. The relational thread, the idea that time is not a container but a network of relations between things, runs through the most modern accounts and deserves to be drawn together, because it reframes the whole question. In the thermal time hypothesis, time comes from the state of a system rather than the system living in time. The mathematics that powers it, the Tomita-Takesaki modular flow, is genuinely deep. Given a certain kind of algebra of observables and a state, technically a KMS state, the mathematical signature of thermal equilibrium, there arises automatically a one-parameter flow, a natural sense of progression, without any external clock being assumed. Ravelli and Conné's insight was that in a generally covariant theory, where no coordinate time is privileged, this state-dependent flow might be all the time there is. The direction and rate of time would then be read off the thermodynamic condition of the world, not off a background stage. And Ravelli demonstrated the idea has teeth. From the KMS state of the cosmic microwave background, the thermal bath filling the universe, The thermal time hypothesis recovers the standard cosmological time of the expanding Robertson-Walker universe. The time that cosmologists use is retrieved as the modular flow of the radiation that fills space. Picture a room with no clock and no windows, where the only way to tell that time is passing is to watch a cup of coffee cool toward room temperature. The relaxation of the coffee toward equilibrium defines a direction and a pace. You could calibrate how much time has passed entirely from how far the cooling has progressed. The thermal time hypothesis proposes that the universe is that windowless room writ large. Time is not an external hand on a dial, but the direction in which thermal states relax, read from within. The persistent worry, which Ravelli names himself, is circularity. Calling a state equilibrium seems to presuppose the very time you are trying to derive. Whether the modular flow genuinely produces time or merely reflects a time smuggled in through the notion of equilibrium is unresolved. But the ambition is unmistakable, and it is shared across every serious quantum gravity program: to make time an output of physics rather than an input, a feature that emerges from a fundamentally timeless or static substrate. Step back and notice the pattern across all of it. Page and Wootters deriving change from static entanglement. Ravelli and Conne deriving flow from thermal relaxation. Barber dispensing with time entirely in favor of a landscape of nows. The wheeler-dewitt equation refusing to tick. The past hypothesis importing the arrow through a boundary condition. Gödel showing the theory permits worlds with no lapse at all. Different mathematics, different motivations, and one convergent implication. At the deepest level physics can currently reach, time is not a fundamental flowing thing. It is either a relation, an emergent gradient, a perspective, or a coordinate on a static structure. And the flowing present we feel so certain of appears in none of the fundamental equations. That is not a fringe reading assembled to sound provocative. It is where the mainstream of theoretical physics has been pushed, reluctantly in many cases, by the mathematics of its own best theories. What does it mean that the more precisely we describe the world, the more thoroughly the present tense disappears from the description? The honest answer is that we do not fully know. It could mean that flow is genuinely an illusion of perspective, an artifact of being an observer with memory embedded in an entropy gradient, the mainstream reading. It could mean, as Ellis and Smolin and Maudlin insist, that our theories are incomplete precisely where they drop the present, that they have mistaken a limitation of the mathematical language for a discovery about reality. The block universe is the most economical account of the evidence we have. Whether economy is truth here is the one thing the evidence cannot tell us. And a physicist who claims otherwise has crossed from what the measurements show into what they prefer to believe. Now let me give the dissenters their full due, because they are serious physicists and philosophers, and the block is not unanimous. George Ellis, the South African cosmologist, argues for an evolving block universe, later refined with Tony Rothman into the crystallizing block universe. Ellis accepts the block geometry, but insists the block grows. The past and present are real, the future is not yet. The present is the real leading edge of space-time, where, as he puts it, The potential of the future becomes the certainty of the past, where quantum indeterminacy resolves into definite events and gets locked into the fixed structure behind it. On this view, time genuinely passes. The block is being built, moment by moment, at its crystallizing surface. The evidence Ellis points to is exactly the evidence the static block struggles with: irreversibility, and the definite outcomes of quantum measurements that seem to convert open possibility into settled fact. Where does Ellis's view strain? On the same rock the localists threw at Reetdijk-Putnam. To define a global present, a single surface where the crystallization is happening everywhere at once, you need a preferred way of slicing space-time into now surfaces. And relativity's whole lesson is that there is no preferred slicing. All frames are equal. Ellis has technical proposals, defining the present via proper time along special world lines threaded from the Big Bang, the Ricci eigenlines, but the tension with the democracy of frames is real, and it is the strongest scientific objection to his account. Lee Smolin goes further still. In his 2013 book, Time Reborn, he argues the entire block universe consensus is a mistake. That time, the real succession of present moments, is the one truly fundamental thing in nature, and that even the laws of physics evolve over time. His motivation is partly to make cosmology testable and to escape what he sees as the sterility of a frozen universe. But Smolin runs into what he himself calls the meta-laws dilemma. If the laws evolve, what governs how they evolve? A meta-law? And what governs that? He concedes he cannot solve it. It is a heterodox position, taken seriously because Smolin is a serious thinker. But it carries an unpaid debt at its centre. And Tim Maudlin occupies a subtle middle. Maudlin argues the direction of time is metaphysically primitive, not derived from entropy, not reducible to a boundary condition, but a fundamental fact, with the laws producing later states from earlier ones. He is blunt about the fashionable claim that passage is an illusion. He calls it just flatly false, and says physicists have been misled by the mathematical language they use to represent the physical world. But note carefully what Maudlin does and does not reject. He still accepts a block ontology. All times exist. His fight is not over whether the future exists. It is over whether time has an intrinsic direction and productive character. Even the fiercest defender of time's reality here grants the block its 4 dimensions. I find that convergence quietly striking. Line the dissenters up, Ellis, Smolin, Maudlin, and notice how much they concede. Nearly all of them accept the geometry. The argument is not really about whether your life is a 4-dimensional object. The evidence for that is overwhelming. The argument is about whether there is, in addition to the geometry, a real, moving, directed passage, objective becoming. And on that specific question, here is what the evidence can and cannot do. It cannot settle it directly. This is the honest edge, and I promised we would stand on it. Bradford Scow, the MIT philosopher, surveyed every serious theory of robust passage in his 2015 book, Objective Becoming. The moving spotlight, in which all times exist but a special light of presentness slides along them, and its variance. He judged the moving spotlight the best of them, and then rejected it, defending the block on a devastatingly simple ground. Contemporary physics doesn't need to use the objective passage of time to explain anything. That is the crux. Every experiment we can run, every muon, every flying clock, every GPS fix, every 2-photon time from entanglement demonstration is fully accounted for by the static geometry plus the entropy gradient. Objective passage does no measurable work. It is not that we have ruled it out, it is that nothing we can observe requires it. And, by relativity's own light-speed limit, we can never observe the distant, fixed future that would confirm the strongest version of the block. The claim that the future is already real is, at bottom, the most economical interpretation of unimpeachable mathematics, not itself a measured fact. So here is where the evidence leaves us, stated as precisely as I can. The geometry of the block universe is as secure as physics gets. Your life is a 4-dimensional object, worldlines have fixed proper time lengths, there is no universal now, and the sense of a single flowing present has no counterpart in the fundamental laws. The felt passage of time is best explained today as a perspectival, entropy-driven phenomenon. The past hypothesis setting a low entropy beginning, and thermal or relational accounts explaining how internal observers read change off a static whole, with page and wootters mechanism demonstrated on 2 photons in Turin. That is the resolution the evidence supports. And here is what stays open, honestly. Whether, on top of that geometry, there is a real objective passage. Ellis's crystallizing edge, Maudlin's primitive direction, is not settled by any experiment we currently have, and may not be settleable. How time is recovered from the frozen wheeler-dewitt equation of quantum gravity is unsolved. Why the universe began in its extraordinarily low entropy state is named but not explained. And whether there is, after all, some preferred cosmic frame, a physical now that relativity's democracy of frames would forbid, is a question the data itself has recently reopened. That last one deserves a moment, because it is the closest thing to a live experimental crack in the whole picture. There is a hint in the sky, and it is contested. The cosmic microwave background has a dipole, one side of the sky slightly hotter than the other, standardly read as the signature of our own motion at 369.82 kilometers per second in a particular direction. That interpretation says the dipole is purely kinematic, just our velocity, with no preferred frame implied. But in 2021, Nathan Seacrest and colleagues measured the dipole in a completely different way, using the distribution of 1.36 million distant quasars from the Catwise 2020 infrared catalogue. If the quasar dipole were also just our motion, it should match the CMB one. It pointed roughly the same way, but came out about twice as large as the motion interpretation predicts, a tension reported at 4.9 sigma, a chance probability of about 5 in 10 million. Dam and colleagues confirmed it at 5.7 sigma in 2023. If real, a mismatch like this would suggest the cosmic rest frame is not merely our velocity. It would hint at something the pure relativity of frames picture does not expect. I have to be scrupulous here. This is contested, not established. Reassessments through 2024 and 2025 argue the significance is inflated by the large slice of sky blocked by our own galaxy and by the clustering of quasars. It may evaporate. But it is exactly the kind of place where an assumption as deep as "there is no preferred frame" gets tested rather than assumed. And that is what keeps this an open science and not a closed story. What does it mean that the deepest question about time, whether it truly flows, turns out to be one our instruments cannot reach, sitting just past the light-speed horizon of what can be observed? It means we have arrived exactly where good physics should arrive, at a resolved geometry and an honest boundary. The equations that run the world do not contain the present tense. Everything urgent about being alive, this moment, its singular reality, the fact that it is happening now and not then, is invisible to the fundamental laws. Whether that says something profound about the universe, or only something about what it is like to be an observer embedded in it, riding the entropy gradient with memory pointing one way, is the question the science hands back to you, unclosed. It does not close it with a maker, and it does not close it with mere chance. It leaves it standing. Before I bring this to an end, sit with one number for a moment. The muons over Mount Washington were living 9 times longer than they should, because their clocks ran slow along their worldlines. The flying cesium clocks came home permanently out of step with the clock that stayed. Those are not thought experiments. They are the world telling you, in nanoseconds, that your now is not the universe's now. That time is something local to a world line, not a tide that lifts all things together. Take a moment with that. The next time you feel a moment slipping away, consider that in the geometry we can actually measure, it is not going anywhere. You are. Let me bring this exploration to its close. We started from the thing you cannot doubt, that you are moving through time, leaving a vanished past behind and reaching toward an unmade future. And we watched the relativity of simultaneity strip away the universal now that intuition rests on. We saw the Lorentz transformation reassign time to distant events with a single term, v minus x over c squared. And Minkowski's space-time interval reveal the invariant structure beneath every observer's disagreement. We traced worldlines and proper time, and we grounded them in things that genuinely happened. Muons surviving 9 times too long above Mount Washington, the hafele-keating cesium clocks flying as Mr. Clock and returning permanently out of step, the CERN storage ring proving it is speed and not force that bends the clock, the GPS satellites detuned to 10.22999999543 MHz before launch so they would run true once dilated. We stood on the Riertdijk-Putnam argument and Penrose's Andromeda paradox, and let Stein and Mermin push back that relativity's present is only ever local. We went into the frozen wheeler-dewitt equation, Page and Wootters' change without change, demonstrated on 2 entangled photons in Turin. Ravelli and Kahn's thermal time read off the microwave background, Barber's timeless Platonia, Gödel's rotating universe with its closed time-like curves, the Boltzmann brain reductio, Price's retrocausality, and McTaggart and Pryor's century-old fight over whether, thank goodness that's over, points at anything real. And we weighed the dissenters, Ellis's crystallizing block, Smolin's fundamental time, Maudlin's primitive direction fairly and found how much even they concede to the geometry. Here is where the evidence leaves us, and I will state it without hedging where hedging is not warranted, and with full honesty where it is. The geometry of the block universe is settled to the nanosecond. Your life is a four-dimensional object, a world line complete from end to end, its length measured by proper time. There is no universal present, and the flowing now you feel appears nowhere in the fundamental laws. The felt passage of time is best explained today as a perspectival, entropy-driven phenomenon, a low-entropy past read from inside by observers whose memories point one way, whose clocks and cooling coffee and shattering cups all slope down the same gradient. On the science, that is the strongest account standing. And here is the edge, named plainly, where the science stops and does not pretend otherwise. Whether a real objective passage rides atop that geometry, physics cannot now settle, and relativity's own light speed limit may forbid it from ever confirming the block's boldest claim, that the distant future is already real, because no signal from that future can reach us to be checked. How time emerges from the timeless wheeler-dewitt equation is unsolved. Why the universe began in its extraordinarily improbable low-entropy state is named, not explained. Whether there is, after all, a preferred cosmic frame is a question the quasar dipole has cracked open and not yet closed. The deepest question, whether time truly flows or only seems to from within, sits just past the horizon of what any instrument can reach. Science describes with breathtaking precision how time behaves, why there is a moment that feels like now at all, and whether that feeling touches something the equations leave out is a question it hands back to you, unclosed. It does not answer it with anything, and it does not pretend the question has gone away. If you found value in this exploration, consider subscribing. It helps these deep dives reach more curious minds who would rather sit with a hard, honest question than settle for an easy one. And if the piece that stays with you is that frozen equation, a universe whose wave function does not tick, and the puzzle of how anything like change could emerge from a fabric with no time in it at all, there is a related exploration waiting on the end screen and in the description, following that same thread toward where time might come from. It is worth the descent. Every moment you have ever lived still sits at its own coordinate, unmoving exactly where it always was. Your first breath and your last, not a journey between 2 points, but the two ends of a single finished shape. Nothing in the block is lost. It is only that you can stand in one place and call that place now. You are not traveling down the river of time. The river was never there. Time is the shape you are. Good night.